Hello everybody, and thank you for tuning in. Um, and welcome to lesson 3. So we're still talking about contact forces. Okay. So we're still on forces, and we're talking about contact forces in this case. So in the previous lesson, we discussed 3 types of contact forces: friction, tension, and compression. Okay. And the last type of contact force that we're going to talk about here is the normal force. Okay. It's the normal force. So we need to understand what a normal force is. Okay. We can start by defining normal force. Start by defining the normal force. So, what is a normal force? Okay. So, normal force is the force that a surface will exert a surface will exert on an object that is placed on it. So this contact force is preventing all of us from penetrating the ground. From penetrating the ground. And then the other important thing you need to know here is that what? The normal force always acts perpendicularly to the surface. perpendicularly to the surface. So perpendicularly, what does that mean? Okay, this word, what it means is that what the object is acting away from the surface, okay, directly away from the surface, okay, is what is directly, or you can say exactly away, exactly away to the surface. Oh, sorry, exactly away from the surface. Okay, so let me use diagrams here to to illustrate the point. Okay, say you have three situations here. Okay, you have an object here. Okay, and this object is on a surface. It's resting on a surface. Okay, it's resting on top of the surface, and then you have another situation where the same object is resting on an incline. So the surface this side this time is not horizontal. It's an inclined surface like this. Okay. Or it could be inclined in another direction. Like that. So the object is still on top of the surface, okay? And is in, so you can say it's inclined up or inclined down. The normal force, okay. So in each case, what's happening? There is the force of gravity which is acting directly downwards here, okay? The weight of the object, okay? In each case, you have the weight, or we can say Fw, okay? So the weight of the object is acting downwards, okay? Exactly downwards. The weight in this in all the cases weight. So now the normal force is always perpendicular, meaning it's acting directly away or exactly away from the surface. So in this case, the surface is horizontal, okay? If you have a horizontal surface like this, okay? If you have a horizontal, so the normal force is acting upwards like that, okay? So it's exactly away from the, so the normal force in this case, okay, let me do it this side. So this is the normal force here, the one that's going up, perpendicular to the surface. So the normal force is here, okay? Normal force. And then in this case, the normal force is still going. So the normal force will go in a what? in this direction. So it will go up away from the surface like that. So it goes directly away from the surface like this. So in our case, this is the normal force here. And so in the third case here, in the third case, the normal force is going directly away from the surface, not parallel or not diagonally. It's going directly away. Okay. So that's how the normal force is different from weight. So weight does not depend on the surface. Weight is always straight downwards like this. It goes straight down and it does not depend on the surface where the object is. So normal force here, we can say Fn. And then in the last case, this is the normal force here. The normal force is up there. We can say Fn. Say Fn. So the other, okay. So in all these cases, okay, what did I say? I said that the object is resting. So there are cases where the object is moving, it's not resting. So in that case, it means the object is in motion. Okay, so in all the three cases that you see here, this case, that case, and that case, all these three cases here, the object is resting on a surface. Okay, so what would happen if we apply a force and we make the object to move? Okay, so okay, consider a diagram below. Consider a diagram below. A boy is using a rope. A boy is using a rope to pull a block across a rough surface. So 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 we have a block here. A block of mass m, and the block is being pulled by a boy. So it's on the floor here, or we can say it's on the ground, and it is being pulled to the right. So like that by a boy. So it is being pulled So a rope is being used here. So now, what will happen? How will how will how do we represent the forces acting? So again, you see, it's across a rough surface. Okay, what does that mean? It means that the surface is not smooth. That's what it means. So it's not smooth. So meaning what? There is friction. That's what it means. Okay. And we remember that friction always, from the previous lesson, that it opposes the motion. So if this thing is being pulled to the right, the boy is on the right side of the block. Okay. So the forces acting, so the normal force in this case has to be represented with other forces, along with other forces. So we have the weight, and then we have the normal force. So the surface is horizontal here. So the normal force is perpendicular, meaning it goes directly away like that. And then, so this is the weight here. The weight always goes down directly. Weight or FW. Right. And then there is the normal force. Okay. Changed. There is the normal force. There's the normal force. Fn. And then to the right, we have what? With the tension, because we have the rope. So there's tension, because a rope or a string is being used. And then Ft, like that. And then to the right, we have the friction. So it's in the opposite direction to the tension, because the tension is the one that causes the movement in this case. So to the left, you have friction. Or you can use a symbol here. It's capital letter and small letter. Capital letter and small letter. Yes, friction. So if there is movement, okay, this is what you do. This is how you represent. So these are the forces that are, there is tension, there is frictional force acting in the opposite direction, and there is weight going down, and then there is normal force, which is perpendicular or directly upwards or directly away from the surface. Okay. So now it would be the same if okay, let's say if the object was being pulled up the incline, okay? You can have a case like this where the object is being pulled up. So you can have the boy on an inclined surface like this. So the boy is here and is holding the rope. Say that the incline is still rough, okay, meaning there is friction, okay. So you could have the boy like this, on an inclined surface. And is pulling the object upwards up the inclined surface here. Okay, so the forces that are acting there, what would be? It would be, we would represent the forces like this. We always start with the weight that is going down. Okay, so the weight is going like that. The weight, or FW. And then there is applied force or tension up the incline, and then there is the frictional force in the opposite direction. Okay, so the tension would be up the incline. So in this case, it wouldn't be to the right because it's on an incline. So the tension would be like this. It would go up the incline, and the normal force would still, so it would be directly away from the surface like this. It would act in this direction. Okay, like that. So this would be the normal force here. The normal force would be in this direction because of the surface. Then Fn, the tension is here, and then this is the friction. So F and small letter. So it's capital letter and small letter here. It's not the same case. It's lowercase and uppercase. It's lowercase and uppercase letters. Okay. So yes, I think that this is a great lesson on what? On normal forces. Okay. So I think let's leave it here for normal forces. And this is the last type of contact force that we're going to discuss here. Okay. So again, thank you for tuning in. I hope this was helpful, and leave your questions in the comment section and let's keep the engagement going. Okay. Ask me questions that you don't understand, and I will iron out your confusions. Okay. If you're confused about something, I will help you out. Okay? So I hope you tune in for lesson 4, and thank you for tuning in for lesson 3. Cheers. Bye bye for now, and take care.